2 databases. That's what 1 year of work bought GitLab, not 200 services. 2 Postgres databases out of 1. 193 tracked issues. 7 phases. A team formed the year before that just to plan the split. And GitLab had the easy version of this problem. 1 company, 1 code base, every caller of every table sitting in the same repo. 1 year. 193 issues. 2 databases. Hold those numbers because the decision that produced them is sitting in your architecture doc right now. Split the services, do the data later. So that's the invoice. This is what it looks like at a company still running up the tab. Datadog runs 1 relational database shared by more than 30 teams, 326 tables at the end of 2023, 257 by April 2025. Out of those 30 plus teams, 2 have fully moved off it. 2. The program runs in 3 phases. Logical separation first, private schemas per domain. That one started in the first quarter of 2024 and finished about a year later. Access reduction started in that same quarter. Physical separation started in the third. Both are still scheduled to run through 2026. Datadog is straight about how they got there, and I respect that. A small group chasing product market fit cuts overhead wherever it can, and 1 database is less overhead than 4. Nobody drew this on a whiteboard and called it the target state. It accumulated. Now put the architecture diagram on screen. 2 boxes. That's the part everyone agrees on. Billing and shipping. Separate repos, separate pipelines, separate on-call rotations, separate scaling. Both of them talk to the same Postgres instance. Both of them read the orders table. Draw it that way and it still looks like 2 services. Nobody argues about the line at the bottom. That line is what let you ship the split in a quarter instead of 2 years. So price out what you actually bought. Network calls, partial failure, red trees, 2 deploy pipelines and version skew between them. Distributed tracing so you can find out where a request died. What you were buying all of that for was isolation. 1 team changing their thing without asking anyone. That's the part that didn't arrive. And you can't see the missing half on any diagram because the coupling isn't a box or an arrow. It's a column name. It's 2 teams agreeing on what the customer ref column on orders means. Same meaning on Tuesday as it had on Monday. Nobody ever wrote that down. Deferring it is a defensible call, by the way. Migrating the data is the expensive half. It's slow and risky, and there's nothing to demo at the end of it. Splitting the code ships this quarter. Splitting the data ships in some other VP's tenure. Every incentive in the building points one way. So let's find out what you're actually holding. Start with the migration nobody thought twice about. Billing owns the orders table. Billing decides customer ref is dead, because billing stopped writing it 2 releases ago. 1 line in a migration file reviewed by 2 billing engineers who are both correct. Ships on a Tuesday afternoon. Green pipeline, green deploy. Nothing red in the logs. Shipping still selects that column. Every label they print reads it. There was no API call between these 2 services for anything to version. No contract test to go red, no consumer list to check. Shipping finds out at runtime in production from a customer. Counter signals that would have caught it. Compile error no, type checker no, contract test no, a PI version bump no, deprecation header somebody could grab for no. Every mechanism our industry built for changing an interface safely assumes the interface is a request. This one's a column. And this is the part that took me too long to see. Before the split, you had 1 deployable and 1 unit of change. After the split, you've got 2 deployables and still 1 unit of change. Any modification to that schema gets planned, sequenced, and released across both teams. 2 services, 1 database, 1 unit of change. That's a monolith. You just gave it a network. Want the consumer list? Go and get it. Postgres will tell you the orders table took 9 million index scans this month. It won't tell you which services made them or which columns they cared about. You can pull queries out of PG stat statements, but that's a sample of what ran. It isn't a contract for what's allowed. Datadog put it better than I'm going to. Teams trying to evolve their data models discover that their database schema is their API. and they have no way of knowing who else depends on it. That's not a metaphor, it's an interface with consumers you can't enumerate. Fine. So why does this survive contact with 3 smart teams and a roadmap? Martin Fowler named this shape before microservices existed. An application database has exactly one application in front of it. That's what makes it easy to change. One owner encapsulates every use of it. An integration database has several. Integration is the entire point of it. His objection is structural, not aesthetic. A schema serving 2 contexts has to satisfy both at once. So it drifts more general or more complex or both. The orders table stops being billing's model of an order. It becomes the union of what billing needs and what shipping needs. Nobody can name the concept it represents anymore. Then there's the coordination tax, and that one scales badly. Microservices.io lists it as the first drawback of the pattern, in plain language. A developer on one service has to coordinate schema changes with every other service touching those tables. At 3 teams, that's a thread in Slack. At 30, it's a program with a steering group. Watch what a column drop really costs at that size. Someone proposes it. Someone goes looking for the readers and gets counts instead of names. So they ask in a channel and wait a week. Because silence is the only approval mechanism the schema has. Then they ship it behind a flag and keep the column 2 more quarters, just in case. That's the cheap version. And here's why the migration you deferred never happens. Every quarter you ship features, and features add tables and readers. The estimate to split goes up. It climbs faster than anyone's appetite for a project with no user-facing outcome. So it loses planning again, to work that's cheaper than it was last quarter. Next quarter, both of those numbers are worse. By year 3, the orders table has readers you didn't authorize and can't remove. Billing writes it, shipping reads it, analytics reads a replica, support has a dashboard on it, there's a nightly job somebody wrote in 2022, and the team that designed the table has been reorganized twice, so the people who'd have to approve a change are in practice nobody. That's the argument. Now the public numbers from teams who published theirs. GitLab's monolithic Postgres had become a common source of incidents, their words, not mine. Continuous integration tables were doing 49% of the write traffic on their own, about 1900 writes a second. Merge requests took another 20%. All of it had to land on one primary. They were hitting the ceiling of a single VM at 96 vCPUs. The CI portion alone ran about 4.7 terabytes, roughly a third of the whole database. Splitting that one workload out took a year and 193 issues. The queued over is where it gets entertaining. Auto vacuum on the largest CI tables had the logs they needed, so they killed it mid-migration. Often connections from old SSH sessions kept the database busy. Replica lag on the new CI cluster ran about 3 times the main one. Actual write down time under 5 seconds. Back at Datadog, more than 30 teams sit on that one database. 2 had made it through all 3 phases when they wrote this up. Not because 30 teams are slow, because moving one team's tables means proving nobody outside that team still depends on them. So what do you actually do on a Monday with a system that already looks like this? 3 coping patterns are worth knowing, and all 3 are honest about being partial. A database view hands a consumer a narrow projection. It's read only, so it does nothing for writes. A wrapping service puts a thin service in front of the tables. That turns a database dependency into a service dependency you can version. Change data capture ships a copy to whoever needs one, and you own the staleness. The order matters more than the destination. Datadog didn't start by moving tables. They started with private schemas, database roles, and table-level ACLs. Cross-domain foreign keys came out of the ORM first. Physical separation came last, once nothing outside the owning team touched those tables directly. Which means the honest target for most teams isn't a database per service. It's a named owner per schema, with permissions that enforce it. Postgres will hand you that boundary today, using roles you already know how to write. The database per service purity comes later, if it ever comes. And here's the line to say out loud in a design review. If nobody will fund the data split, the second service isn't ready to exist. Ship a module inside the monolith with its own schema and its own owner. It gives you every boundary you are actually asking for, and it costs you nothing you can't undo. Go back to that architecture doc. The two boxes are fine. The line at the bottom is an interface, and the problem isn't the sharing. It's that no name is attached. Every other interface you own has a version and somebody whose weekend it ruins. This one has a table name. Which brings back that year GitLab spent. That year wasn't the price of splitting a database. It was the invoice for every quarter they didn't, arriving at once with interest. A shared schema is a public API that nobody agreed to own, version or retire. GitLab's bill came to 1 year and 193 issues. Nobody's going to send you an estimate for yours.